Hi Madison. On this worksheet, the directions state to solve the following systems using elimination. So there's four main methods we can use to solve systems of equations. One is graphing. Two is using elimination, sometimes referred to as linear combination. Also substitution, and we can use matrices. Elimination is probably the most common method. In any situation, we are trying to find a combination, like a code, of a number you can plug in, and when you add these two particular numbers, you get 3. And then when you take those two values for x and y, when you substitute them into the second equation, you end up with 5. So, rather than just guessing and checking until you find a combination, this particular direction asks us to solve using elimination. So the first thing I'm going to do is I'm going to organize this problem. I'm going to think of it as this is going to be my x column, my y column. These will be my answers on the opposite side. So I have 1x plus 1y equals 3. And then I'm going to switch the order here. So this was a positive 1x, and this was a positive 3y. I'm going to set that equal to 5. And there's more than one way to do this. So the next step would be to examine the x values and examine the y values. And ask yourself, is it easier to cancel out the x's or the y's? And the way we'll cancel this out is we'll multiply one equation by a particular number that would allow us, when I rewrite this equation again, it would allow us to be able to cancel out one of the variables. So for instance, what is opposite of positive 1? And the answer is negative 1. If you combine positive 1x and negative 1x, they would cancel out. They would be eliminated. So to turn this positive 1x into a negative 1x, I need to multiply it by a number. What times positive 1x equals a negative 1x? The answer is negative 1. So I'm going to distribute that to all the terms with this in this equation. Negative 1 times positive x, negative 1 times positive 3y, and negative 1 times 5. Okay, so now I've set up the equation so that when I combine them downward, the x's will cancel because 1x and negative 1x are directly opposite each other. They cancel out. It gives you 0x, and 0 times any number is 0. Positive 3y and negative 3y, different signs, subtract, keep the sign of the larger number. 3 and negative 5, different signs, subtract, keep the sign of the larger number. And now we're going to solve for y. Negative 2 is being stuck by multiplication with the y. Opposite of multiplying is dividing. We say these cancels out, but in reality they turn into the number 1. And negative 2 divided by negative 2 is 1. Now this original problem, remember, it's like solving some type of a code. You have to figure out what is the value of x and the value of y, so that when you substitute them into the first equation, you get 3. And when you substitute them into the second equation, you end up with 5. So we know one of the answers is 1. Now you have the choice, doesn't matter which one you use, to look at the first equation and the second equation and decide which equation looks easier to you. I think the first equation looks easier. So I'm going to rewrite the first equation, and now wherever I see a y, I substitute in the value 1. X plus 1 equals 3. To solve for x, and subtract 1, and x equals 2. And we're going to write our official answer as an ordered pair, 2, 1. That means if you graph this equation and if you graph this equation, they would cross at only one place, and it would be at the place on the Cartesian plane at the point 2, 1. So 2 plus 1 is 3, and 3 times 2, 3 times 1 plus 2 is 5. So one more problem we've had questions with on this particular page. Very similar problem. 2x minus 3y equals negative 4. 1x plus 3y equals positive 7. In this problem, it's nice because they've already organized the x's and the y's and the numerical values that do not contain xy on the opposite side of the equal sign. So it's already been organized for us. And even better, when I examine the x's and the y's, I can see that the y's by themselves, when I combine these two equations, will cancel out. So I don't need to multiply any equation by a specific number because they're already set up to eliminate one another. So negative 3y and positive 3y, they cancel out. You end up with a 0y. 0 times any number is 0. 2x and 1x is 3x. Negative 4 and positive 7, different signs. Subtract, keep the sign of a larger number. Now to solve for the x, we're being multiplied opposite, multiplying is division, and x equals 1. Go back and look at the two systems of equations and ask yourself which equation of the original two looks easier to you. I think the second one. So 1x plus 3y equals 7. There's no wrong answer. Wherever I see an x, I'm going to substitute in for this problem the value of 1. But this isn't 11. It's 1 times the value of 1. So make sure to put parentheses. 1 times 1 is 1 plus 3y equals 7. To isolate the y and solve, I'm going to start by subtracting 1. And now opposite of multiplying is dividing. And y equals 2. Final answer is ordered pair, xy. And if you substitute in 1 for x and 2 for y, you'd end up with negative 4 in the first equation. 1 for x, 2 for y. Doing the math, you'd end up with 7.